You have been told a story about automation. It goes like this. Humans were tired of work, so we invented machines to do the work for us. A spinning wheel here, a steam engine there, a robot arm in a factory. And now, artificial intelligence, writing code, answering emails, and making decisions faster than any person ever could. That is the simple version. But it is not the real story. Automation was never just about saving time. It was always about power. Who works, who controls the work, who profits from the work, and who gets replaced when the machine learns to do it better. This is the history of automation, and it begins much easier than you think. Long before factories, long before computers, long before robots, humans were already trying to escape the limits of the human body. A person can only grind so much grain by hand. A person can only carry so much water. A person can only pull so much weight before exhaustion wins. So we borrowed strength from the world around us. The first great automation was not a robot. It was an animal. Oxen pulled plows. Horses carried goods. Donkeys turned meals. Suddenly, one person could do the work of many. A farmer who once scratched the soil with a simple tool could now cut deep roads through entire fields. This changed everything. More food meant bigger villages. Bigger villages meant cities. Cities meant rulers, taxes, armies, and empires. Automation did not just make work easier, it made civilization larger. But animals still had limits. They got tired. They needed food. They died. So humans looked for power they did not breathe. Water was one of the first answers. Thousands of years ago, people learned to guide rivers through wheels. The current turned the wheel. The wheel turned gears. The gears crushed grain, sawed wood, pumped water, and hammered metal. For the first time, nature itself was doing the repetitive work. A river did not demand wages. It did not sleep. It did not complain. As long as the water flowed, the machine worked. Then came wind. Windmills spread across Persia, the Islamic world, and Europe. They ground grain, drained marshes, and powered workshops. A good mill could replace dozens of workers. It could turn invisible air into useful motion. This was the first lesson of automation. If you could capture energy, you could multiply labor. And whoever owned the machine owned the multiplication. In medieval Europe, peasants often had to bring their grain to the lord's mill. They paid for the right to use it. The machine saved labor, but it also concentrated power. The people who control the mill control a part of everyone's bread. The pattern will appear again and again. A machine arrives promising freedom from work. Then someone builds a gate around it. For centuries, automation remained mechanical. Wheels, gears, levers, pulleys, water, wind, animals, and human heads are working together. Then, in the 18th century, something changed. The machine was no longer waiting for a river or the wind. It carried its own power inside it. Steam. The steam engine was one of the most important inventions in human history because it broke the ancient connection between work and muscle. You no longer needed a horse, a river, or a strong back. You needed fuel, metal, pressure, and heat. At first, steam engines pumped water out of coal mines. Then they powered textile mills, then trains, then ships, then entire cities. The world began to move at machine speed, and nowhere did this hit harder than the textile industry. Before industrial automation, clothes was slow. Spinning thread and weaving fabric took enormous human labor, often done inside homes by families. Then machines like the spinning jenny, the water frame, and the power loom arrived. A single machine could do the work of many hands. Clothes became cheaper. Production exploded. Factory owners became rich. But the workers saw something else. They saw their skills being turned into gears. In early 19th century England, textile workers known as the Luddites smashed machines in protest. Today, the word Luddite is used to mean someone afraid of technology. But that is not what they were. They were not stupid. They understand exactly what was happening. The machines were not simply replacing labor. They were changing who had bargaining power. A skilled weaver once controlled the craft. A factory worker controlled almost nothing. The machine set the pace. The owner set the wage. The worker followed the rhythm. Automation had entered the factory, and the factory had entered the human body. Time itself became industrial. Clocks told workers when to arrive, when to eat, when to stop, and when to begin again. The sun no longer ruled the working day. The factory bell did. This is one of automation's quietest revolutions. It does not only automate tasks, it automates people around the tasks. By the late 19th century, automation had transformed manufacturing, transportation, mining, agriculture, and war. Steamships crossed oceans. Railroads stitched continents together. Telegraph lines carried messages faster than horses, faster than ships, faster than human imagination had been prepared for. Then electricity arrived. Electricity made automation smaller, cleaner, more flexible, and more precise. Machines no longer needed to be arranged around one giant steam engine. Motors could be placed anywhere. Factories could be redesigned. Work could be divided into smaller and smaller pieces. And then came the assembly line. In 1913, Henry Ford's moving assembly line changed industrial production forever. Before Ford, workers moved around the product. After Ford, the product moved past the workers. Each person performed one task, the same task, again and again and again. The result was astonishing. Cars that once took more than 12 hours to assemble could be produced in a fraction of the time. The Model T became cheaper. Millions of people could afford automobiles. A machine once reserved for the wealthy became part of ordinary life. But there was a cost. The assembly line did not just automate production, it automated attention. A worker no longer built a car. He tightened the same bolt all day. He repeated one movement until his body became part of the machine. Ford understood the bargain. He paid higher wages because the work was exhausting, monotonous, and hard to endure. Automation had made goods cheaper, but it had also made work more mechanical than ever. Then came the next leap. Machines that did not just move, machines that could decide. The earliest automatic control systems were simple but powerful. A thermostat could sense temperature and switch heat on or off. A governor on a steam engine could regulate speed. These devices did something profound. They closed the loop. A machine could measure the world, compare it to a goal, and adjust itself. That idea became the foundation of modern automation. During the 20th century, factories filled with sensors, relays, switches, and control panels. Chemical plants, oil refineries, power stations, and telephone networks became too complex for human hands alone. Automation moved from muscle to judgment. Then war accelerated everything. World War II forced governments to build machines that could calculate, aim, decode, and coordinate faster than humans. Anti-aircraft systems predicted where planes would be. Code-breaking machines attacked encrypted messages. Early computers performed calculations that once required rooms full of people. After the war, those machines did not disappear. They evolved. In 1947, the transistor was invented. It made electronics smaller, faster, cheaper, and more reliable. Then came integrated circuits, then microprocessors, then software. Automation was no longer only made of steel. It was made of instructions. This changed the nature of machine. A mechanical loom could weave fabric. A software-controlled machine could be reprogrammed to do something new. The same hardware could follow different commands. Automation became flexible. In 1961, the first industrial robot, Unimate, began working on General Motors' assembly line. It handled hot metal parts that were dangerous for humans. This was the image people had been waiting for: the robot worker. An arm of steel, no fatigue, no injury, no lunch break. Robots spread through factories, especially in automobile manufacturing. They welded, painted, lifted, sorted, packed, and assembled. They were precise. They were tireless. They were expensive at first, but they got cheaper. And once again, the old promise returned. Machines will do the dangerous work. Machines will do the boring work. Humans will be free for something better. Sometimes that was true. Automation did remove people from deadly mines, toxic factories, and repetitive injuries. It made products cheaper, safer, and more consistent. It raised productivity beyond anything previous generations could have imagined. But the second lesson of automation is this: the benefits do not distribute themselves. Someone decides where the savings go. To workers in higher wages, to customers in lower prices, to owners in higher profits, to governments in military power, to platforms in control. Automation creates abundance. Politics decides who receives it. By the late 20th century, automation left the factory and entered the office. The personal computer looked harmless at first: a screen, a keyboard, a blinking cursor. But it was one of the most powerful automation devices ever created. Spreadsheets automated accounting. Word processors automated typing and editing. Databases automated filing cabinets. Email automated letters, memos, and office communication. Search engines automated memory. Entire layers of clerical work began to shrink. A task that once took a department could now be done by one person with software. This did not feel like robots taking jobs. There were no metal arms, no sparks, no factory floor. But it was automation all the same. The machine had learned paperwork. Then the internet connected everything. Suddenly, automation was not trapped inside one company. It could coordinate across the planet. Supply chains became algorithmic. Warehouses tracked inventory in real time. Financial markets traded in milliseconds. Ads followed people from site to site. Recommendation systems decided what music you heard, what videos you watched, what news you saw, and what products appeared in front of you. Automation had moved into behavior. It was no longer only making things, it was shaping choices. And most people did not notice because the interface was pleasant. A feed, a search bar, a button that said buy now, a map that told you where to go. Behind the screen, machines were ranking, pricing, routing, predicting, and nudging. The factory had not disappeared. It had become invisible. Then came the algorithmic workplace. Drivers were managed by apps. Warehouse workers were tracked by scanners. Delivery routes were optimized second by second. Customer service agents followed scripts generated by software. Freelancers were ranked by platforms they did not control. In the old factory, the machine set the pace with gears and belts. In the new factory, the machine sets the pace with data. And then, in the 20th century, automation crossed another line. It began to automate language. For most of history, machines replaced physical labor first, then repetitive calculation, then record keeping, then coordination. But language felt different. Writing, speaking, designing, translating, teaching, coding, persuading, these were supposed to be human things. They belong to knowledge workers, artists, analysts, lawyers, programmers, and managers. Then artificial intelligence began producing text, images, music, code, voices, video, and decisions. This was not automation of the hand. It was automation of the draft. And this recent chapter has stats. In 2012, deep learning broke through in image recognition and showed that machines could learn patterns from huge amounts of data instead of being programmed rule by rule. In 2017, the transformer architecture gave AI a new way to process language and context at scale. In 2020, large language models began showing that text itself could become a universal interface. Instructions, code, summaries, plans, analysis, and conversation all flowing through the same channel. In 2012, conversational AI moved into public view. The machine was no longer hidden behind a form, a search box, or a dashboard. You could simply ask. In 2023, multimodal systems began combining language with images, audio, video, files, and screens. The interface widened from typed commands to human context. By 2024 and 2025, the frontier moved again. Models were no longer only answering. They were using tools, browsing interfaces, writing and running code, calling APIs, operating computers, and tracking their own work. This is the recent automation jump. The machine is moving from response to action. By February 2026, OpenAI's Codex series made the shift explicit. GPT 5.3 Codex was no longer framed as only a coding helper. It was described as an agent that could research, use tools, execute complex work on a computer, and help secure software by finding vulnerabilities. By June 2026, Notebook LM, provided by Google, was being pushed in a similar direction for research. A notebook was no longer only a place to store sources and ask questions about them. It could help discover sources, run code in a cloud environment, build visualizations, and turn research into documents, spreadsheets, slides, and other outputs. And in the same moment, Anthropic's reported Mythos class models showed the other side of the frontier. Cloud Fable 5 was described as a public safeguard version of a more powerful Mythos system, with restrictions around cybersecurity, biology, and chemistry. The point was not only capability anymore, it was containment. Because security is where this becomes concrete. Some weaknesses do not live in one obvious line of code. They live between old code and new code. Linux has shown this pattern again and again. In 2026, researchers disclosed copy-fail, a Linux kernel flaw in the crypto and page cache path. The reported weakness had been sitting across kernels shipped since 2017. The dangerous path moved through connected kernel service layers, touched shared memory cache, and crossed a protective privilege boundary, allowing a normal local user to gain root-level access. That is the kind of weakness an advanced security agent can surface during an update to one subsystem. It does not only read the new code, it asks, What odd assumption the new code has made reachable? Dirty pipe had a similar shape. An old uninitialized pipe buffer flag existed before it became catastrophic. Then a later refactor changed the meaning of that flag, and suddenly read-only files could be changed in memory. OpenSSH had its own version. In 2024, regression showed how a safety guard for a 2006 bug could be accidentally removed during a 2020 login update. A class of vulnerability that had already been fixed quietly returned. Sudo, the authorization control system, had facing the same issue. A subtle argument parsing bug introduced in 2011 lived for almost a decade because the danger was not in a single obvious command. It was in a mismatch between parsing, escaping, and privileged execution. And the XD backdoor showed the darker version. Sometimes the update is not where the weakness is found. Sometimes the update itself is the attack. This is why frontier security agents matter. They can inspect the update and the old assumption at the same time. They can ask, what did this refactor make reachable? What safety check disappeared? What trusted input became executable? What harmless optimization now crosses a privilege boundary? The breach may have been waiting for years. The agent did not create it. It found a map. That is what the newest automation race is becoming. Not just who can build the strongest agent. Who can build the strongest agent that can still be governed? The first version, the email, the summary, the legal template, the design markup, the customer reply, the software function, the marketing plan, the report. AI did not need to be perfect to be disruptive. It only needed to be good enough to change the economics of the first attempt. That is why this moment feels different. Earlier automation competed with muscle. Industrial robots competed with routine factory labor. Office software competed with clerical process. AI competes with pattern-based thinking. And a lot of modern work is pattern-based thinking. But the newest form of automation goes even deeper than that. For most of computing history, machines could only follow structured commands. Click this button, fill this form, run this program, choose from this menu. Type the command exactly right. If the instruction was not written in the machine's language, the machine could not act. The language models changed the interface. For the first time, a system could accept free-form human language, messy language, incomplete language, emotional language, contextual language, the kind of things people actually use. And with multimodal input, that interface expanded even further. Text, images, audio, video, documents, screens, gestures, and environments could all become instructions. The machine was no longer confined to a narrow menu of commands. It could interpret intent. That unlocked another level of automation. Before this, automation usually meant building a workflow, a fixed sequence of steps. Do this, then that, then that. A human designed the process and a machine repeated it. But once the system can understand open-ended input, observe results, use tools, and adjust its next action, automation stops being a straight line. It becomes a loop. First, there is a workflow. Then the workflow becomes automated. Then the automated system begins to measure performance. Then it optimizes. Then the loop closes. The system can observe what happened, compare it to the goal, change the plan, and try again. That is the birth of the agentic system. Not just software that follows instructions, but software that pursues an objective. Software that can plan, act, evaluate, and improve its own process over time. This is why AI automation feels so different from the machines that came before it. A factory robot automates a motion. A spreadsheet automates a calculation. A website automates a transaction. But an agentic system automates the loop itself. It can take the vague human command, turn it into steps, use tools, check the outcome, learn from failure, and continue. Workflow becomes automation. Automation becomes optimization. Optimization becomes feedback. Feedback becomes self-improvement. And once the loop closes, the machine is no longer just doing a task. It is participating in the management of the task. That is a much deeper shift, because the most powerful automation is not the machine that replaces one action. It is the system that keeps finding new actions to replace. This does not mean every job disappears. History almost never works that cleanly. Jobs change, tasks move, new roles appear, old roles shrink. Some people become more powerful with the machine. Others become easier to replace because of it. That is the third lesson of automation. Automation rarely removes humans completely. It rearranges them. Some move up, some move down, some are pushed out. Some become supervisors of systems they barely understand. Some become data for systems that supervise them. And that is where the line has to be drawn. Because what makes humans human is not that we can calculate faster than a machine. We cannot. It is not that we can repeat a motion more precisely than a robot. We cannot. It is not that we can store more facts than a database. We cannot. What makes humans human is that we decide what the tools are for. We choose the question. We choose the goal. We choose the meaning of the answer. We complete the final puzzle from consciousness, judgment, memory, emotion, and responsibility. A tool can extend the hand. A tool can extend the eye. A tool can extend memory. A tool can extend speed, and now a tool can even extend parts of thought. But it must remain a tool. It can assist thinking. It can accelerate processing. It can reveal patterns we might have missed. It can help us build, test, compare, summarize, simulate, and decide more clearly. But it should not replace the human act of deciding what matters. Because the danger is not that machines become useful. The danger is that usefulness becomes authority. The danger is that we slowly stop asking whether the tool is serving the human and begin shaping the human around the tool. That is when automation stops being assistance and becomes control. So the question is not whether automation is good or bad. The question is who it serves. Because automation has always carried two futures inside it. In one future, machines take over dangerous, exhausting, repetitive work, and humans gain time, health, education, creativity, and freedom. In the other future, machines become tools for surveillance, speed up, death killing, unemployment, and control. Both futures are real. Both have happened before. A watermill can feed a village or enrich a load. A factory can make goods affordable or trap workers in brutal conditions. A computer can expand the mind or monitor every keystroke. An AI system can help a doctor catch disease earlier or help a company fire workers faster. The technology does not decide the ending by itself. Power does. And that is why the history of automation is not really a history of machines. It is a history of leverage. Every major leap gave someone more leverage over the physical world, over production, over time, over information, or over other people. The plow multiplied the farmer. The mill turned one river's flow into the work of many hands. The steam engine turned fuel and heat into portable industrial power. The assembly line turned discipline and timing into mass production. The computer turned calculation into something fast, cheap, and repeatable. The internet turned coordination into a global network. Artificial intelligence turns patterns into drafts, predictions, and decisions. And the agentic systems turn execution itself into a repeatable loop. Now we are approaching the next question. What happens when automation is not just inside factories, offices, phones, and apps? What happens when it becomes a layer over everything? Your schedule, your shopping, your driving, your medical records, your education, your job applications, your banking, your entertainment, your government services, your relationships, your memory, a world where machines do not simply perform tasks but anticipate them, a world where software does not wait for instructions but acts as an agent. Booking, buying, negotiating, filtering, applying, creating, deciding. That could be incredibly useful. It could also become the most complete control system ever built. Because if an automated system can act for you, someone will try to make it act on you. That is an old pattern wearing new clothes. Automation begins as assistance, then it becomes infrastructure, then it becomes dependence. And once people depend on it, whoever controls it has power. This is why the next chapter matters, not because machines are suddenly waking up, but because institutions are. Companies see automation as profit. Governments see it as administration and security. Workers see it as both help and threat. Consumers see convenience. Investors see scale. Everyone is looking at the same machine and seeing a different future. But history gives us a warning. The machine itself is never the whole story. The real story is the contract built around it. Who owns it? Who can inspect it? Who benefits from it? Who is harmed by it? Who can refuse it? Who is accountable when it fails? These questions mattered with the mill. They mattered with the factory. They mattered with the assembly line. They mattered with the computer. And they matter even more now. Because the most powerful automation is not the machine that replaces your hands. It is the machine that quietly shapes what your hands are allowed to do. For thousands of years, humans have built tools to escape labor. But again and again, we discover that escaping labor is not the same as escaping control. Automation can free time, but it can also measure time. It can reduce work, but it can also intensify work. It can remove drudgery, but it can also remove bargaining power. It can make life easier, but only if the ease is not purchased with dependence. So the history of automation does not end with robots. It does not end with AI. It does not end with some perfect machine doing everything for us. It ends with a choice that every generation has had to face. When a machine can do the work of many people, will it be used to give many people better lives? Or will it be used to give a few people more control? That is the real history of automation, not the story of humans becoming obsolete. The story of humans repeatedly building systems more powerful than themselves, then struggling to decide who those systems belong to. And right now, the struggle is not in the past. It is happening around us. In every workplace adopting AI, in every warehouse run by algorithms, in every platform ranking human labor, in every company promising efficiency, in every government dreaming of automated control, in every person wondering whether the next tool will make them freer or easier to replace. Automation has always promised to save us from work. But the question was never only what work the machine can do. The question is whether we can keep tools as tools, whether we can use them to amplify thought without surrendering judgment, whether we can let them accelerate the process without handing them the purpose, whether we can build systems powerful enough to help us, but limited enough to remain answerable to us. Because what makes humans human is not speed, it is not precision, it is not endless memory, it is consciousness choosing what matters. And if automation is going to serve humanity, that must remain the final piece of the puzzle. The machine can calculate, the machine can optimize, the machine can execute, but the human must decide why. And who gets to live freely in the world is what our decisions create.